Okay, let's take a look at problem number 2 on sample test 1. The formula M equals negative 0.03 N plus 27 models the percentage of high school seniors who used marijuana, which is represented by M, during the 30 days prior to being surveyed. And N represents the number of years after 1980. So this is our model right here. Is our model. And if you recall from our discussion in class, a model gives you estimates or predictions for different values of M and N. It doesn't give you the actual data value. And I mentioned in class that sometimes I put a little hat over there to remind me that it's a model, but that's not necessary. Okay, so let's take a look at the first problem here, A. Use the formula to estimate, again, see that we're estimating, the number of seniors who used marijuana in 2005. Okay, so we don't have any bar graphs or pictures to look at. We just have our formula or our model here. So in order to estimate the number of seniors who used marijuana, remember, that is finding the value for M, we need to know the value for N, the number of years after 1980. So to do that, we take 2005, which is the year we're interested in, and we subtract from that our base year, 1980. Okay, so what does that give us? 25 years. So that means when we use our model and our formula here, we're going to let N equal 25. So now we go to a model and we say negative 0.03 times 25 plus 27. That equals negative 0.75 plus 27. And that equals 26.25. So this model, according to the model, (26.25% of high school seniors used marijuana in the year 2005. Okay. Now the next two sections asks us to find the M-intercept and then the N-intercept. The M-intercept is our vertical intercept. So the vertical intercept would have our value for N be 0. So just to help me out here, I always do a little kind of graph on the side of my paper. And here I know that this is the N-axis and this is the M-axis. And my M-axis is going to tell me the percentage of high school seniors. And then along my N-axis, I represent the number of years after 1980. So to find a value, an M-intercept, I know that I live on my Y-axis, which means my N value is 0. I'm going to be some point along this vertical positive axis here. So to find that value, I put in 0 for N, and I solve my equation. So this goes to 0, so M equals 27. So to interpret this, I need to know, what does a 0 mean? I know that 27 is 27% of the high school seniors, but what does a 0 mean for the year? If you recall, the numbers that N represent are the number of years after 1980. So since N is 0, that's our first base year, 1980. We're not any year beyond 1980, and we're not any year back into the past. So to interpret this, you could say something like this. There's lots of ways to say it. According to the model, 27% of high school seniors used marijuana in 1980. Now let's suppose you didn't use the phrase according to the model. Then you could say, we estimate that 27% of high school seniors used marijuana in 1980. Being very careful that you don't make a statement like 27% of high school seniors used marijuana in 1980, because we don't know the actual percentage. So you can either use this phrase according to the model, or to state both of your values, your M value and your N value, with the word estimate. Both of those are acceptable. Okay, let's go down to our N-intercept. Our N-intercept would be, here's our M axis, percentage, and N is the number of years. So we would be some point on this axis. So here we would have 0, the value 0 for M. So I'm going to rewrite my model once again. And again, I don't memorize this. I just think about what my picture looks like. M is 0. So now I'm solving for N. I'm trying to figure out how many years after 1980 I could predict that 0% of high school students used marijuana in the 30 days prior to being surveyed. So to solve this equation, I would subtract 27 from both sides, and I would get negative 27 equals negative 0.03 N. Now to solve for N, I divide both sides by negative 0.03. And that's going to give me N equals 900. Well, if I add 900 to 1980, I get the year 2880. So what does this mean? This is telling me that according to the model, no students, no high school students used marijuana in 2880. So this is one of the times when we'd want to really consider whether our model makes sense here. I mean, we really think 0% of high school students will be using, not, 0% of the high school students will have used marijuana in 2880. Well, who knows, right? So this is what our model gives us for a finding, but we may want to say this could be an example of model breakdown, or we might just want to write our answer and move along. Okay, now let's actually take a look at a graph with the actual data. So the graph below shows the percentage of high school seniors who used marijuana or alcohol during the 30 days prior to being surveyed. Does the formula used to determine the percentage of seniors who used marijuana in 2005 underestimate or overestimate the actual percentage displayed by the graph? Estimate by how much? Okay, well, what did our formula predict for 2005? We predicted that in 2005, 26.25% of high school seniors would have used marijuana. So let's take a look at our graph to see the actual value here. So let's take a look. I'll just use a little different color pen. So here's the year 2005. If I go up to my graph, it looks like that's about 22%. So my model overestimated. My model overestimated the actual percentage of high school students by about 4.25%. That's problem number 2.